SMPS versus transformers. These are two ways to convert electrical power, but, with very different approaches. Let's break it down. First, what exactly do we mean by converting electrical power? Well, most of our devices can't use the electricity that comes straight from the wall. The voltage is too high, the current is too strong, or the type of current, alternating current or AC, just isn't what the device needs. So we need a way to change that power into something usable. That's where SMPS and transformers come in. Let's start with the transformer, the classic workhorse of electrical engineering. A transformer is a simple, passive device. It's made up of two or more coils of wire called windings, wrapped around a core, usually made of iron or some other magnetic material. When you plug a transformer into an AC power source, the alternating current in the primary winding creates a changing magnetic field in the core. This magnetic field induces a voltage in the secondary winding, and that's how you get a different voltage out. The ratio of the number of turns in the primary and secondary windings determines whether the voltage goes up or down. For example, if you have a transformer with 100 turns on the primary and 10 turns on the secondary, and you put 120 volts AC into the primary, you'll get 12 volts AC out of the secondary. It's a simple, elegant solution, and it's been around for over a century. But transformers have their limitations. They only work with AC, not DC. They're also big and heavy, especially if you need a lot of power. That's because the core has to be large enough to handle the magnetic field, and the windings need to be thick enough to carry the current without overheating. If you've ever picked up an old wall wart or a vintage radio, you know how hefty these things can be. Now let's talk about SMPS, or switch mode power supplies. These are a bit more complex, but they're everywhere in modern electronics. An SMPS takes the incoming AC power, rectifies it to DC, then chops it up into high-frequency pulses using electronic switches, usually transistors. This high-frequency AC is then sent through a much smaller transformer, which steps the voltage up or down as needed. Finally, the output is rectified and filtered again to produce a smooth DC voltage. Why go through all that trouble? Well, by operating at a much higher frequency, tens of thousands or even hundreds of thousands of cycles per second, the transformer in an SMPS can be much smaller and lighter than a traditional transformer. That's why your phone charger is so tiny compared to the brick-sized adapters of the past. Let's look at a real-world example. Imagine you have a laptop charger. Inside you'll find an SMPS circuit. It takes the 120 or 240 volts AC from the wall, converts it to high-frequency AC, and then steps it down to the 19 volts DC your laptop needs. The whole process is efficient, compact, and lightweight. On the other hand, if you open up an old stereo amplifier, you'll probably find a big, heavy transformer. It takes the AC from the wall and steps it down to a lower AC voltage, which is then rectified and filtered to produce DC for the amplifier circuits. It's simple and reliable, but not nearly as compact or efficient as an SMPS. So, what are the main differences between SMPS and transformers? First, efficiency. SMPS units are generally much more efficient, often reaching 80% or even 90% efficiency, while traditional transformers can lose a lot of energy as heat, especially at lower loads. Second, size and weight. Because SMPS operate at high frequencies, their transformers can be much smaller and lighter. That's why modern electronics are so compact. Third, versatility. SMPS can handle a wide range of input voltages and frequencies, making them ideal for international travel adapters and universal chargers. Traditional transformers are usually designed for a specific voltage and frequency. But it's not all upside for SMPS. They're more complex with more components that can fail. They can also generate electrical noise, which can interfere with sensitive audio or radio equipment. Transformers, on the other hand, are simple, robust, and produce very little electrical noise. Let's break down the basic operation of each, step by step. For a transformer, you plug it into the wall, AC current flows into the primary winding, a magnetic field is created in the core, and a voltage is induced in the secondary winding. That's it, no moving parts, no electronics, just physics. For an SMPS, the process is a bit more involved. First, the AC from the wall is rectified to DC. Then, a high-speed switch, usually a transistor, turns the DC on and off rapidly, creating a high-frequency AC signal. This signal passes through a small transformer, which steps the voltage up or down. Finally, the output is rectified and filtered to produce a stable DC voltage. Here's another example: LED lighting. Most modern LED bulbs use SMPS circuits to convert the high-voltage AC from the wall to the low-voltage DC the LEDs need. Older fluorescent lights, on the other hand, often used heavy transformers and ballasts. Or consider audio amplifiers. High-end audio gear sometimes still uses traditional transformers because they're quiet and reliable. But most modern consumer electronics have switched to SMPS for their efficiency and compact size. In summary, both SMPS and transformers are essential tools for converting electrical power, but they do it in very different ways. Transformers are simple, reliable, and great for certain applications, but they're big and heavy. SMPS are efficient, compact, and versatile, but more complex and sometimes noisy. As we move forward in this video, we'll dive deeper into the pros and cons of each, look at real-world examples, and help you decide which is best for your needs. But for now, you've got the basics. Two different approaches to the same problem, getting the right power to your devices. Stick around as we explore the power showdown between SMPS and transformers in more detail. First, the transformer. It's a time-tested technology, simple, reliable, and built to last. A transformer transfers energy between two coils using electromagnetic induction. It steps voltage up or down, but only works with alternating current power. But here's the catch. Traditional transformers are big and heavy, especially at low frequencies like 50 or 60 Hz. Now, meet the switched mode power supply, or SMPS. It does the same job, but faster, lighter, and more efficiently. By switching power at high frequencies, SMPS units use much smaller transformers and waste less energy as heat. SMPS units can reach up to 95% efficiency. That's why they power our laptops, phones, and TVs. Downside, SMPS can generate electrical noise, known as EMI, not ideal for sensitive audio or radio systems. So which one should you use? For simple high-power AC jobs, go with a transformer. For compact, efficient, regulated power, use an SMPS. SMPS versus transformers, different tools for different tasks. Know the difference. Power your world smarter.